Now, in this video, we are going to discuss laws of chemical combination. As time progresses, we will start dealing with chemical reactions, how elements combine to form their products. Now, for this to happen, there are laws that guide the chemical reactions. An element does not just combine with another element to form the product, but they do so in relation to some laws that is guiding their reactions. So in this video, we are going to treat those laws. There are 4 laws in which chemical reactions are based upon. So we are going to be discussing them gradually. In this video, we are going to discuss the law of conservation of mass and the law of definite proportion. Now, when we look at the law of conservation of mass, first one is now this law states that during an ordinary chemical reaction, matter can neither be created nor destroyed. This is what this law says. Matter can neither be created nor destroyed. I believe this was taken from the theory of John Dalton. Remember one of his theory, matter can neither be created nor destroyed. So this is the first law of conservation of law of chemical combination. Now, when we talk about this conservation, it means masses are maintained during chemical reactions. There is no manufacture of another mass. There is no increment in the products and the reactants. All are conserved. The masses are conserved. That comes to do with the balanced chemical reaction. So any chemical equation or any chemical representation that is not obeying the law of conservation of mass is not acceptable in chemistry. So it must obey the law of conservation of mass. Now let's take an example of a chemical equation that illustrates this law. If we have a sodium hydroxide, now we need to balance the equation. This is 4, it should be 2. This is 2. Alright, I believe this equation is balanced here now. Now, if you look at this equation now, it obeys the law of conservation of mass. The equal number of masses here must be equal to the number of masses here. Now, let's look at this. Let's see if this is true. This is 4 into the relative atomic mass, or less the molar mass of sodium is what? 23. Plus oxygen is 16, plus 1 for hydrogen. Molar mass of hydrogen here is 1. Plus, now this is 2 multiplied by carbon is 12, oxygen is 16 times 2 is 32. Now, this is for the reactants now. Now our products, we are not trying to prove if at all this law, this equation obeys the law of conservation of mass. And then we can do that by trying to calculate the total number of masses of the reactants and the total masses of that of the products. If they both are the same, it obeys the law of conservation of mass. So this is 2 into sodium is 23, so multiplied by these 2 is 46. Carbon is 12. Oxygen 16 times 3 is 48. Okay, and then for water, this is 2 into oxygen. Hydrogen is 2. Oxygen is 16 plus 2 is 18. Alright, now let's try to add up everything together. Add this together, we should be getting here 160 grams. This is 88 grams. This is 212 grams. And this is 36 grams. A ratio sign. When we add this together, 160 plus 88, you get 240 When you add this together, you get 248 grams, and this also 248 grams. Alright, now the total number of masses of the reactants is 248 grams, and the total number of masses of the product is 248 grams. So there is no difference, there is no addition in the sum total of masses of the products, and there is no difference. This is 248 and this is 248. So this now tells us that this equation obeys the law of conservation of mass. This is applicable in all chemical equations. That is where we start talking about balancing a chemical equation, which will be in our next video. So I know most of you will be worried. Why do I have to put 4 here? Or why did sodium have to come with carbonate oxide there, CO3? I mean, why must we put 3 here whereas we have 2 here? And then no problem. We are going to treat this in the next video, which is chemical equation, balancing chemical equation, in which case you're not going to understand how this happens. For the sake of this video now, I just want you to understand that every chemical equation in chemistry has to obey the law of conservation of mass, which in this case, the sum total of the masses of the reactants must be equal to the sum total of masses of the products.